Hello, good morning, everyone. Yesterday we had discussed about EIGRP and OSPF. So before starting with the advanced concept like VPN, we'll just brush up with BGP, then we'll move on to the VPN. So if we talk about BGP, BGP stands for Border Gateway Protocol. In which layer it works? Which layer of OSI? Very good.
Layer 4.
Layer 4, okay then. Any other answer? So I got layer 3. So I got layer
7.
Layer 7. So exactly in which layer it works? Is it in the network layer, or transport layer, or application? Network layer. And it should have protocol number. What BGP has? BGP has a port number. What is that port number? It is 179. 170. So works in the application layer, layer 7. RIP and BGP works at application layer, where RIP also has a port number of 520 that uses UDP services, whereas your BGP works on the TCP services. Means before doing any data transfer, first it will establish a three-way handshake, then it will do the data transfer. So we call BGP as an application layer protocol. Like your HTTP, HTTPS, Telnet, SSH, FTP, all comes under layer 7. That is application layer. This is for RIP. What are the network layer protocols?
OSPF and UJP.
Any other protocol other than EIGRP and OSPF? What about ICMP? What about your GRE? Now we'll be discussing about this. This is also your network layer protocol because it has a protocol number. Yeah. We'll come back to GRE. What is the algorithm that BGP uses to select the best path? Path vector algorithm. Very good. It uses path vector algorithm. First of all, tell me why we need BGP. We have EIGRP and OSPF, right? Then why we went on to BGP? Yes, anybody?
Establish connectivity between different
ISP.
BGP has more
Can't hear anything.
control on the routes.
Yes.
The traffic.
Is everybody able to hear?
Yeah.
Yes, Ravi, please check your audio. Others are able to hear. Okay. Now, moving on. Tell me, why BGP? Why not EIGRP and OSPF? Correct, right? In ISP, can't we use EIGRP and OSPF?
Yeah, actually, what I know is like in BGP we have more control on the routes or the traffic, and BGP can contain more routes in the routing table.
Okay. Yes. Tell me. Yeah, that is fine. But why BGP? Exterior right. What you're talking is right. In between two different autonomous system numbers. My question is why this? Why BGP? No, that is fine. I got your point. You are telling like between two different ISPs or inside the ISP we use BGP. My question is why only BGP? Why not EIGRP and OSPF? That is fine. Those are what is the interior gateway protocol? This is the exterior gateway protocol. That is been designed, right? But my question is why? Because BGP has more scalability. If you talk about BGP, only BGP can handle more than 8+ lakh routes. If you talk about current routing table of BGP, we have more than 8+ lakh after aggregation. So why we prefer BGP? Because of scalability. This is the first point. Second point is rich in attributes. So what do you mean by this? Let us consider we have R1, we have R2, R3. R6. Let us consider we have a loopback on R6. So if we talk about EIGRP, how EIGRP calculates the best path? Based on bandwidth and delay, correct? What about OSPF? Based on the cost, interface cost. But if you talk about in the ISP, there are many number of routers. You can choose any path. So EIGRP, what it does, it calculates the optimal path based on the bandwidth and delay. But if you talk about BGP, BGP will calculate the best path based on so many attributes. Yes. So I hope you listen about weight, local preference, MED, AS path, origin. These are the attributes. We'll talk about the attributes later. Clear? Any doubts still here? I cannot hear the audio.
No, it's good.
So others are able to hear?
Yeah, you can.
Yes, sir. Yeah, we are able to hear.
Please check, please check. Okay, now moving on. So what are the BGP message types? How many message types we have in BGP? 4. So what are those? Not seeing in the book. Tell me. 4. What are those? Open. Keep alive. So before keep alive, we have update. So we have update. We have keep alive and we have notification. Correct? Now what open is used for? Connectivity, neighborship. What about maintenance? Did open message maintain the neighborship? Only for establishing the neighborship. Why? Because there is a separate mechanism in BGP that will keep track of your neighbors. That is keep alive. What is the by default keep alive and hold on time? No, I can hear. Okay, fine. Tell me. Please make a note. Keep alive is 60 seconds and hold on time is 180 seconds. So every 60 seconds, the router will say, I'm alive. And the neighboring router should also say, he is alive. Then only that adjacency will be stable. Clear? So, yes, any doubts offline? So, okay. If we talk about update packet, again, to exchange the routing information. Keep alive. So every 60 seconds, it is sent just to maintain the neighborship. Maintain a notification. When we get a notification message,
Any topology changes?
any error in your topology, you'll get a notification.
Chetan, can you just repeat why we are using this open message? Establishment means,
To establish the adjacency, establish the neighbor. As soon as you enable BGP, how BGP will form the neighborship? Statically, right? So you need to go and manually enable the neighbor command on R1 and R2. So as soon as you enable the neighbor command on R1 and R2, they will exchange a open message.
Oh, okay.
Before forming neighborship, yes.
Okay.
Yeah?
Thanks.
No. So now, if we talk about BGP states, neighbor states, how many BGP neighbor states we have? 2, 6. So what are those? We have idle, connect, Then 2. Okay. Active. We have open send, open confirm. We have established. Good. You are not visible. You should come in the front. So okay. If we talk about idle message, so why we use idle? So when this will come into the picture, by default, both your routers will be in the idle state. So in connect state, it will try to establish TCP three-way handshake. If successful, it will move on to open send. If it is unsuccessful, it will move on to active state. So if we talk about open send, when we'll send an open send message, when your BGP version, what is the BGP version currently we are using? And your router ID must be unique. Neighbor command should be properly configured. So if everything is fine, then it will move on to the open confirm state. So in open confirm, it is waiting for a keep alive from the neighboring router. So once it gets a keep alive, it will remain in the open confirm state. If it gets a notification, it will again move on to the active or to the idle state, depending on the error. Clear? Now final state is established. Clear? Now. So let us consider we have 3 routes. So BGP works on the autonomous system number concept. So what do you mean by IBGP and eBGP? Within the same AS? Different. Good. So let us consider ASN is IBGP you are forming within the same AS, right? Now tell me, let us consider I have a loop back here. So how many neighbor adjacencies with R1? So I'll form with R2. So R2 will form with R3. Will this be able to exchange? Will you be able to see this route on R3? Yes or no?
No.
Why?
That loop prevention, IGP loop prevention mechanism.
Very good. It is IBGP split horizon. This is how it avoids the loops. It is IBGP split horizon. So how to break this IBGP split horizon rule? Very good. Before that, we can do full mesh. Please try this lab. You can do full mesh. So this route reflector will come into the picture when we want to break this full mesh as well. Yeah. So route reflector and configuration. So now let us consider another topology. So we have R1. So R1 is in ASN1, ASN2, ASN3, R4 is in ASN4. Now tell me how BGP will avoid the loops. Let us consider I'm advertising a loop back /32.
port number.
AS path.
Yes, good. So our router will reject this prefix if it sees its own AS path information on R1. Let us consider R1 has advertised to R2, R2 has advertised to R3. So R3 has advertised to R4. Now, whenever R4 tries to advertise to R1, R1 will never allow this prefix to enter in its BGP table because of AS path. Clear? This is eBGP split horizon. Clear? So now we'll move on to VPN. So your advanced concept, VPN. So VPN stands for Virtual Private Network. So the first question, why VPN? Why we require this? And then we'll see what is VPN. So now, so let us consider the headquarters in Bangalore location. ISP. Delhi. And we have one more site in Bombay location. So now let us consider R1 wants to send any data to R2 or to R3. So how your data is traveling? Through the ISP. Do you think ISP is secure? Let us consider a hacker is sitting here. You can keep track of your data. You can alter the data. There is no confidentiality, there is no authentication, and there is no integrity as well. So in order to provide all these three things, your VPN will provide authentication, confidentiality, and integrity. We'll talk about these three things. There's authentication, confidentiality, and integrity. So what this VPN will do is will create a tunnel over an unsecure network like internet. Site-to-site tunnels. These are not physical tunnels, these are virtual tunnels. Okay. No. So now what do you mean by tunneling? So tunneling, it is a process of encapsulating IP inside an IP header. Now, what do you mean by this? R1. Again, the same topology. So let us consider the IP address between R1 and ISP 192.168.14.0/24. So between ISP and R2 will be 192.168.24.0/24, and between ISP and R3 it will be 192.168.34.0/24. So this will be dot 1, dot 2, and dot 3. So we have a loopbacks 1.1.1.1/32. So why we call IP inside an IP is, let us consider R1 wants to communicate with R2. So now, so what is your outer header? So let us consider I want to ping to 2.2.2. What will be the source IP? What will be the destination IP? So our source IP will be
1.1.1.
and destination IP will be
2.2.2.2.
So now, what will be the inner header? Inner header will be your NBMA IP. So this is 192.168.14.1, and destination IP will be 192.168.24.2. So now somebody is required to carry this, right? That protocol we call it as GR, generic routing encapsulation. So this is your data. Let us consider this is your data. Okay. So now he needs to carry to your remote sites, right? So that's why we have a carrier protocol. We call it as GR. This will carry your data packets. Which one? We are not at created tunnel. I'm just talking about how it carries that. So your tunnel will be having a separate IP, virtual IP. No? Okay. Now if we talk about VPN types. So there are two types of VPN. Site to site, or we also call it as point to point. And second one is remote VPN. So in our syllabus, So we'll be doing site-to-site VPN. So remote VPN we'll learn in security. Now, what do you mean by site-to-site VPN? Now, we have 3 sites. Okay, this is 12.0/24. This is 23.0/24. This is 24.0/24, and this is 25.0/24. Now, so what you mean by site-to-site VPN is, so for each and every site, you need to create a tunnel. So let us consider we have 4 routers. Then how many tunnels we require for full mesh connectivity? How we calculate? We need 6 tunnels. One from R1 to R2, one from R1 to R3, one from R1 to R4, one from R1 to R5. So 3 tunnels are done. Then one from R3 to R4, R4 to R5, then R3 to R4. 6 tunnels we have. So the main disadvantage is as the sites goes on increasing, your virtual tunnels will goes on increasing. Let us consider we have 10 routers. Then we need to have 45 virtual tunnels. So that's why we came up with the concept of DM. So we'll discuss this later. So one more key point to remember about site-to-site VPN is your IPs are fixed.
Hello.
Yes, tell me.
Okay, Chetan, just a doubt. Let's say when we talk about the site-to-site VPN, it will be IPsec VPN, right?
IPsec. So IPsec is just used to provide what security over the
Security, yeah, right. So if let's say if someone asks what is the difference between GRE and IPsec?
GRE never provides your encryption. So that is the downside of your GRE.
Okay, so there is no authentication.
Just encapsulation, right? And decapsulation. Yes, tell me.
Yeah, for in GRE there is no authentication and
there is no encryption as well.
Encryption.
It will be in the clear text, that is plain text. That's why we implement IPsec, Internet Protocol Security. This we'll discuss in DMVP.
Okay, cool. Yeah.
Clear?
Yeah, clear.
Okay. So a small hint about this remote VPN, how it works. Just tell you. So if you talk about a remote VPN, let us consider ISP is there and we have a Facebook server. So everybody uses Facebook. Happy, right? So we have a FB server. So what do you mean by remote VPN is, let us consider you are logging to your Facebook server in the morning 10 o'clock. You are at home. So what is the IP you are getting? Let us consider it as 192.168. Private IP, right? So let us consider 12.2/24. So at 12 o'clock, you are in the cafe, sitting and enjoying with anyone. Okay. So let us consider the IP. Again, it will change. Let us consider it as 15.5. /24. Again in the evening, where you want to go? Anywhere, right? Okay. So at 6 o'clock, log out from my office and go to a restaurant. So again, the IP will change. Let us consider it as 25.5. So in remote VPN, your IPs are not fixed. So Facebook server IP is fixed, whereas these IPs are not fixed. So in site-to-site VPN, your IP addresses are fixed always.
Is it the difference between
No,
IP
there are a lot of
servers?
differences. I just simply.
Oh, okay.
So this you will learn more deep in security. So we have
Okay.
site-to-site and we have DMVPN. Okay.
Yep.
Okay. Done? No. So now we'll do a lab. So this will be 9168. So 34.0. So for tunnel between R1 and R2, we'll use the IP 172.16.12.0/24. Between R1 to R3, we'll use the IP 172.16.13.0/24. And between R2 to R3, we'll use 172.16.23.0/20. These are your tunnel IPs. So one more very important point to remember. So whatever connectivity we are providing through the ISP, we call it as underlay. So I'll be using these terminologies in your DMVPN. So this is your underlay. So whatever connectivity we'll be providing with the help of these tunnel IPs, we call it as overlay. So this is your underlay. So over that, we are creating tunnels that we call it as what? Overlay. Please make a note.
Okay, so basically the ISP IPs are underlay
Yes,
IP. Right?
underlay, yes, very correct.
Chadan, is it the terminologies we are using in DMVPN or normal?
DMVPN also, even in
Yes.
this site-to-site VPN also.
Okay.
So the connectivity through ISP, no, from R1 to R4, R4 to R2, we call it as underlay. So the connectivity over these tunnel IPs, we call it as overlay. Overlay. So underlay, overlay. Sorry, not overlay. Done. So if we talk about site-to-site VPN, I told IPs are fixed, right? So inside the tunnel, you need to mention the tunnel source and the tunnel destination for each and every tunnel. So I'll show you in the configuration. No need to worry. Means the IPs are fixed. So we'll go to R1. We'll create a tunnel. Tunnel source will be your NBMA IP. This we call it as NBMA. This we call it as logical IP. Make a note. So I'll talk about that. These are NBMA IPs. So whatever we are providing to the interface, physical interface, we call it as NBMA. And these tunnel IPs, we call it as logical. NBM, non-broadcast multi-access. No. So in order to provide the underlay reachability, we'll be having a default route from R1 to R4, R2 to R4, and from R3 to R4. Create a default route. I hope everybody knows about default route. This is for underlay. And for overlay, you can use any routing protocol like EIGRP or OSPF or BGP as well. No? Getting? Any doubts? Done?
So, overlay, can we provide the overlay static?
You can do that. But easy is very agile. Use any routing protocol. Now, steps to create site-to-site VPN. First step, always make sure your underlay connectivity has reachability. Then configure your overlay. By using any routing protocol. Yeah. Okay. Let's proceed to the lab. So we'll capture the Wireshark as well, and we'll see the tunneling part. So let us consider 4 routers. So what is our ISP? So the IP address between R1 and R2 will be 24. So the IP address between R2 and R3 will be 192.168.23.0. And the IP address between R2 and R4 will be 192.168.24.0. So now, if we talk about tunnel IPs, so between R1 and R3. So how many tunnels we require here? 3. So R1 to R3. So we'll take 172.16.13.0/24. So between R1 and R4. So we'll take the tunnel IP as 172.16.14.0/24. And between R3 and R4, we'll take the tunnel IP as 172.16.34.0/24. So for underlay, we'll be using a default route to provide the connectivity, and for overlay, we'll use EIGRP. I hope everybody knows about EIGRP. How to enable EIGRP? Let's start. What is the first step? What is the first step? Yes,
Let's make sure you underlay connectivity that's
working fine. Okay, first we'll finish off underlay, then we'll move on to overlay. Wait for the console. Using notepad. So I'll share this notepad as well. So on. Okay. So one. So this will be dot 3. So dot 4. Any doubts still here? What? So on R1. Enable config T. So let's provide the host name. R1. So interface 0/0. What will be the IP address? The IP address will be 192.168.12.1 slash. Go shit. So we have a default route. So IP route What will be the next stop?
Dot 2.
So this is the configuration of R1. R2. What is Z0 bar 0? Is 12.2. So Z0 bar 1 will be 23.2.
23.2.
Yes. Z0 bar 2 will be 24.2. Yeah. So on R3, so Z0 bar 0 will be 192.168.23.3.
3.
We have default route. So what will be the next stop? It will be 23.2.
2.
So this is the configuration on R3. Now finally on R4. So Z0 bar 0 will be 24.4. The next stop will be 24.2. We'll copy paste and check the underlay connectivity. Yes. Now, so go to R3 and ping to your R1's IP address. So will I be able to ping?
Yeah.
Yes or no? What about 24.4?
Yeah.
This is my underlay connectivity. Clear? Now.
Yeah.
So how many tunnels is required on R1? How many tunnels I need to create? 3
2. 2.
3 or 2?
2 tunnels.
2 tunnels, right? So one between R1 and R3 and one between R1 and R3. So I need to create 2 tunnels on R1. So go to R1 and create 2 tunnels. So first command, interface. How to create a tunnel? Interface tunnel.
Yes.
You need to give a tunnel interface number. So we'll take 1. So you can consider anything. So let us consider it as 1. Interface tunnel 1. So then provide the IP address. What will be my IP address? Between R1 and R3, it will be 172.16.13.1/24.
24.
Enter. Now you need to specify 2 things. One is tunnel source and tunnel destination. Now tell me what will be my tunnel source. Is it Z0 bar 0 or is it this IP?
It's gig 0 0.
Yes. What about 0? Because how your packet will travel? Through your underlay, right? So always make sure your tunnel source is the exit interface. And what about the tunnel destination? Again, your NBMA IP only. Clear?
Yeah.
So you need to specify two things. One is tunnel source. What is the source of the tunnel? So while mentioning tunnel source, either you can use exit interface or NBMA IP. Now tell me why I can't use tunnel destination as the exit interface. It's okay. I'll just go and mention here. So tunnel source. Let me consider this 0.0. This is my tunnel source. Enter. Now talk about tunnel destination. Why can't I use the interface number?
It's the same device only, right?
Same device. Can I use? Let us consider this is G0/1. Now,
But R1 doesn't know that G0/1 is
yes, who is your destination? That's why you need to mention the NBMA IP only. Source, he knows I am the source. But what about destination? Destination, I don't know. Clear? So you need to mention the NBMA IP. So what is your tunnel destination? It will be 192.168.23.3. Enter. Now your tunnel will come up. Why? Because we have underlay reachability. So your tunnel will first be in the down state. Suppose let us consider we don't have this reachability. So your tunnel will never come up. Please check the underlay reachability. Fine.
Yeah. This is what we call GRE tunnel, right?
Yes.
Till now.
Yes. I'll show you the wireshark. So done. So one tunnel is done. Now one more tunnel we need to create between R1 and R4. So interface tunnel and use tunnel number as 2. IP address. What is the IP address? Between R1 and R4, it will be 172.16.14.1/24. Okay. Now again, you need to specify two things. Tunnel source. Either you can specify it exit interface or I can specify it NBMA IP as well. 192.168.12.1 and tunnel destination. So what will be my tunnel destination?
24.4.
Very good. 24.4. Is up. Show IP interface. Can you see? I have created two tunnels and both are in the upstate. Clear? Now.
So then just one thing.
Yes.
Okay. In R3, actually, we haven't configured the tunnel configurations, right?
Yes. But you have reachability, right? Your tunnel destination is reachable.
Yeah, tunnel destination is reachable.
That's why they came up.
Okay, so the traffic won't pass, right?
No, traffic won't pass. We need to create on R3 and R4, right?
Yep.
Okay, so go to R3 and create two tunnels. So interface tunnel 1. Short form this is. Don't use the short form. The total command is interface tunnel 1. What will be the IP address? It will be 172.16.13.3/24. Tunnel source
is 23.3.
192.168.23.3. What about tunnel destination?
12.1.
192.168.12. So between R1 and R3, I have created a tunnel. Now you need to create one more tunnel between R3 and R4. So interface tunnel 2. What is the IP address? 172.16.34.3/24. So tunnel source will be, you can use exit interface.
Yeah.
And tunnel destination 24.4. Any doubts?
No.
Clear?
Yep.
Show IP. I created two tunnels. Now, so finally, go to R4 and create two more tunnels. So this was a major disadvantage in site-to-site VPN. Let us consider we have 10 sites, then you need to create 45 virtual tunnels. Because these are point-to-point. You need to mention your tunnel source as well as your tunnel destination. So in multi-point GRE, we only specify tunnel source, but not the tunnel destination. Now, we'll discuss about that later. So let me create tunnel 1. Where's the IP address? So IP
It's
address will be
14.16.
172.16.14/24. So tunnel source is 0 bar 0. Tunnel destination will be 192.168.12.1. Done. Create one more tunnel. Interface tunnel 2. IP address will be 12.16.34.4/. What is my tunnel source? G0 bar 0. What is my tunnel destination? Dot 192.168.23. Show IP. So I created 2 tunnels and 2 tunnels are up now. So let us consider a loop back on each and every router. /32 on R1. So on R3, the loop back will be 3.3.3.3/32. So on R4, very good. Okay. Will be 4.4.4. So create the loopbacks on R1. So loopback 0. So IP address will be. I didn't use no shut command, right? How it came up? I didn't use any no shut command.
It's a virtual loopback, virtual IP, virtual interface, right?
Go to R2. Sorry, go to R3, create a loopback. IP address will be 3.3.3/. The R4 as well. Sleepy. So IP address will be 4.4.4. Tell me, will I be able to ping over the tunnel? Let me go to R3. Will I be able to ping to 172.16.34.4?
Should be.
Should be. What about others?
Okay, tunnel interface is up, right? So I think we can ping.
Will not be able. Or a walk. So ping. Sorry, it's his own IP. So who is 34.4? It's his own IP. Wait. Sorry, to 16.34.3. Now will I be able to ping? Will I be able to ping to loopback then?
Loopback, no. Okay. Loopback, I mean the 1.1.1. Yeah, for yeah, loopback, no.
Now. So I need to go to R1 and use the protocol EIGRP. Router EIGRP 1. So how to enable?
Network.
172.16.13.0. 172.16.14.0. Done. I need to enable loopback as well. This is how you enable auto summary. So go to R2. Sorry, go to R3. Enable EIGRP. Router EIGRP1. So network. So 172.16.13.0. Network 172.16.14.0. 34.0 and network loopback, that is 3.3.3.3. Okay. So now go to R4 as well. Rotary RP1. Can I use 2 here? Wait. Can I use 2?
No,
No,
Why?
should be same
maybe
AC.
it's a different age, right? I mean, it's a different.
Okay. So network 172, 16.14.0, network 172, 16.34.0, and the loopback handler. How to check the neighborship? Yes, tell me.
Our tunnel. Yeah, just a doubt, Chetan. Okay.
Yes, tell me.
Let's say instead of enabling EHRP,
Mhm.
let's say if in R1 we
Mhm.
added 2 static routes, one is pointing to 3 and one is pointing to 4.4.4.4,
Mhm.
and the exit interface is tunnel. It should work, right?
It will work.
Okay.
Please. Okay. So now, how to check the neighborship?
Should BGP is enabled? Submit neighbors
So we have 2 neighbors. That too over the tunnel.
channel.
So before checking the connectivity, let me capture this. Okay. So let me go to R3. Ping to 4.4.4.4 using source as 3.3.3. Enter. Go to ping. Just go to the wires. What is the source? Can you see? This is your outer header. And we have GRE and we have inner header. So this we call it as GRE tunnel. So we have IP over IP. Can you see this GRE is sandwiched between your what is the outer header and the inner header? So this is your source, that is 3.3.3.3, and the destination will be 4.4.4.4. Can you see the inner header? It will be it is your NBMA IP 23.3 and 24. Can you see GRE here? So anybody has any doubts?
Why the tunnel is not showing there?
Which tunnel?
I mean the tunnel IPs, right?
I'm pinging from the source, right?
Okay. Okay.
If I don't use source, it will show. Just ping 4.4.4.4. It will show that. 1 minute. Just go to R3. Don't use the source. So now, what is the source? 34.3 is the source and 4.4.4.4.
Yeah, it's changed. It's changed. Yeah. Thanks.
Okay, no problem. So anybody has any doubts till here? So the major disadvantage point-to-point tunnel is you need to create multiple virtual tunnels on a particular route. So that's why we moved on to DMVPN. So one more key point to remember, if you talk about GRE, GRE just provides encapsulation. Means GRE will not provide any encryption or authentication. And it works on the protocol number 47, network link. Protocol number 47. And this is a Cisco proprietary. It was introduced by Cisco in 1994. Just 10 years ahead of your OSA model. OSA was introduced in, that's how I remember, 1984, OSA was introduced. Just 10 years ahead, this was introduced, 1994. It was introduced by Cisco. And it works under network link. So no encryption, no authentication. So in order to provide encryption and authentication, you need to use the protocol called IPsec. So Internet Protocol Security. So this we'll discuss in DMVPN. Okay. So anybody has any doubts still here? I'm done for the day. So you please, guys, please wait. Yes, online guys, any doubts?
I'm good, Chetan.
What about others?
No doubts.
Clear?
Chetan, just a request.
Yes, tell me.
Can you just share your number?
Yeah, take me. 1 minute. Where can I get the recording? You didn't get the drive link, Ravi, still?
Yeah,
No, sir.
Please
Sorry,
provide me mail
I
ID.
yeah. This is my first class, so that's right.
Okay, that's okay. No. So my mobile number is 99 720 33 22. I'll just quickly share this.
are you putting it in chat or?
No, it's enough. I'll just share.
Yeah, I shared my email ID. Would you please share the link for the
Yeah,
drive?
1 minute. Second one is the correct one. First one only I shared.
Yeah.
You got?
1 second, let me check.
Mother. Yeah, tell me. Mother.
Yeah.
Got it, right?
Yeah.
Madan V, right? Yes, offline. Yes. Tell me your email ID.
Sir, this is my first class as well. I have shared the email ID.
Yeah. Tell me. Please put it in the chat box. TV sign. So anybody is left? So anybody needs access for the drive link? Everybody has, right?
Yeah, I do have.
Okay, guys. Okay, today we'll end up, then we'll continue tomorrow. Thank you, guys. Have a nice day.
Yeah.
Bye.
Thank you. Thank you all.